Welcome you all in my video lecture series. Today we are going to discuss about the double integration. This is Rajesh Kumar Jha, Faculty of Mathematics, Department of Mathematics. Before we start the double integration, definitely subscribe our channel for more updated videos. This is the series of the multiple integral. In the double integration, 5 to 6 videos that you can see in coming days very soon. And then we will talk about the triple integration and the application of double integrations. So almost 10 to 12 YouTube videos that you can see on my YouTube channel. So one thing that we have initiated now, there is a Kutum app. On the Kutum app, you can search mathematics lovers. You can associate with us and definitely you can get information on that app also. Some activity also will be performed. The link is here in the description. You can join via this link. Thank you. So once we talk about the double integration, it is basically, if you are aware about the single integration, so it is a successive integration, right? So double integration, we know in this lecture, evaluation of double integration, how we do this. After that, we will talk about the double integration in polar coordinate. Then we talk about double integration by changing the order of integration. Then by change of variable, we will evaluate the double integration and some applications that we can see. For example, area volume you can find by the double integration, and moment of inertia, mass, center of mass that you can find by the double integration. Many more applications you will see in upcoming video lectures. So now we talk about the double integration. Double integration is what? It is a successive differentiation. It is two successive integration it is, right? So one integration that you know, so again double integration that you can do here. Only the thing is, initially in the Intel first single order integration, it was fx only. Here f of xy and you can say dx dy should be there, or in summation of this dx dy, in place of this we can write a. It was what? In the single integration, we were integrating over the between the 2 points. In the double integration, we are integrating over the area. For example, if you see in the x and y domain, suppose this area is given. So we would like to integrate over this area. So what we can select the path. Suppose one way that we are integrating here, and another way we are integrating this way. So first we integrate either in x direction, and then we will move into the y direction. So the double integration symbolically that you can see here. Double integration f of xy dA. So A is this area that you are covering here, this whole area that we can talk about. The function that you require to integrate with respect to dy dx. So here you can see it is y1 y2, that two functions are given. So let's say y1 is equals to fx and y2 is equals to, let's say, gx. So here these two limits says that first we are integrating with respect to y. First we are integrating with respect to y, the function. So we keep x as a constant. And after evaluation, what we see, the whole term will be converted in the form of x, and the simple integration that you can integrate with respect to x by putting the limit a to b. Here a to b is the constant, so this figure will not perform in such a way. From here to here that you can talk about. Okay, if these two limits are constant, suppose I write here a to b and c to d, some function that you want to evaluate. So the area of integration over this region you are integrating, so that will be a to b you are integrating here, and c to d that you can integrate. Okay, so in this way, first a to b that you are moving, and then in this way you are moving, so you will get the values. So in this case, first we have integrated with respect to x, then y. But in the first example, first y, then x. So this will be moved in such a way. So from this point to this point, we are moving in two ways. So this is the method one, and this is the method two that we can think. So second method that you see, double integration, again the limit is a to b or c to d, whatever you can think, and then it is x1 x2. X1 is equal to, let's say it is f of y, and x2, let's say it is g of y. So the again in this case we are integrating with respect to x in this direction, and then we go for y direction. So here we have seen that these two methods, x and y. Now come to the question first. Evaluate the integral 0 to 1, 0 to x square plus y square dA. So again, this is a task to find the limit because dA is given. So as you know, that you can write here y is equals to 0 and y is equals to x. So dA will be what? It is dy dx. So graphically that sometimes required to know. So it is given here y is equals to x. So that we have framed here y is equals to x. Then we talk about this is x is equals to 1 here, and this is what, y is equals to 0. So you have started with x is equals to 0, then y is equals to x, this way and this way. This region of integration that you can see here. So we can draw this region of integration. Okay. So y is equals to 0, y is equals to x is equals to 1, and x is equals to 0 is also there. So double integration that we can perform in such a way, dy dx. So in the place of dA, it should be dy. So be careful when you identify this order of integration. Since 0 and x is written here, so by default the limit of y it is given. So it is dy dx. First we integrate with respect to y. So by integrating, what we get, it is x square into 1 here. So it is x square y, and it is y cube by 3. Put the limit 0 to x. By putting the limit, it is simple. By putting lower limit 0, it will be 0. Whole term will be 0. By putting the limit x, it is x cube plus x cube by 3 that we get. So ultimately it is what? It is 4 by 3 x cube dx. By integrating, what we get, it is x to the power 4 by 4. So this 4 will be cancelled here. So 1 by 2, 1 by 3 that we have taken outside. By putting the limit 0 to 1, your answer is 1 by 3. So basically in this example, only two things that you need to take care. First, dA is given, so order of integration that you must remember. In most of the cases, if you change the order of integration with the same limit, so you may have a wrong answer. Later on, we will talk about the order of integration by changing the order of integration. In that case, limit should also be changed. So by giving this example, the dA, that is dy dx, that we have performed. And second thing is, you must be good in integration. If you know how to integrate, definitely you can get the right answer. Other also, the visualization of the graph or the domain of integration, that is also important. So sometimes you require to draw the graph as well. Now come to the next question, that is 0 to a, 0 to square root of a square minus y square, and the function f of xy is given what? It is square root of a square minus x square minus y square. So what we can see here, it is given here x is equals to this one and x is equals to, because it is function of y. So if you open it, it will be x square plus y square is equals to a square. So the whole circle that we have defined here, but it is positive. So in the positive direction only we can think of, and that we can see x square plus y square is equals to a square. Now this is x is equals to 0, this is y is equals to 0, and y is equals to a, that point. So this is the first quadrant that we can define, or the region of integration. Now we have to take care about the order of integration. So clearly the first limit is a function of y. So you have to differentiate with respect to x. X is equals to 0 and x is equals to square root of a square minus y square. So you are integrating in this direction. So by simple integration that you require to remember the formula. So by integration it is x by 2 square root of a square minus y square minus x square, and this that we get the result. So by putting the limit, if you put the lower limit here by x is equals to 0, the first term will be 0 as well as second term will be 0. If you put the upper limit here, the first term will be 0 and the second term that you get it here, pi by 2, that you get sine inverse 1, it is pi by 2. Now come to the second integration with respect to y. So here pi by 2 we have taken outside, and this 2 also that we have taken outside. So pi by 4 we got here. So by integration it is a square y and it is y cube by 3. Now put the limit. By putting the limit, what we get, it is a cube minus a cube by 3. So it is 2a cube by 3. So finally pi a cube by 6, that you get the answer. Again in this question we have seen that the order of integration is important according to the limit. Integration formula is important, and the region of or domain of integration that you must visualize in which manner you are integrating. So in the coming lecture we will talk about the type 2 of the double integration. Till subscribe our channel. Thank you. So once again, thank you for watching this video. You can like, subscribe and share these videos with your friends. Around 10 to 12 video lecture will be for double and triple integration. Thank you for watching this video.